Take a look at this picture. Let's do a quick review of our air mass codes before we get into looking at the air masses that impact the US. What air mass code do you think is associated with the source region that we see in this picture? Most students pretty quickly jump to continental, pretty obviously continent and not an ocean, so we know the first letter is C. Now we have some students who think, it's obviously hot. So what would the second letter be? Is it going to be equatorial? We know it's warm at the equator. Or is it going to be tropical? Which one do you think? There's enough information in this picture for us to pretty definitively decide if we're looking at continental equatorial or continental tropical. Well, if you watched the last video, you already know that I told you that continental equatorial air masses don't exist. But if you didn't remember that, the way that we can for sure tell this is a tropical air mass is simply because it's a desert. And if you think back to what we have learned about the pressure belts that we find around the planet, we know that around the tropical, subtropical highs, we have a lot of sinking air because of that high pressure. And that sinking air under the subtropical high is really what creates all of the world's deserts. So the fact that we're looking at a desert here tells us that we are definitely in the tropical belt, and this would be a continental tropical air mass. How about this one? This is a little tougher. I mean, obviously it's maritime, we're over an ocean. It's a little tougher, and we really probably can't say just based on the picture, but what could it be? More than likely, equatorial or tropical. And I say that simply because there's clearly a lot of water vapor in the air, and in particular, we see this cloud right here with a lot of vertical development. And that indicates that our air is unstable, that we have some warm rising air, and it's growing a thunderstorm. Now, it could be maybe summer polar air mass, maritime polar, but more than likely, we're looking at an equatorial or tropical air mass here, just because we can see that we have a lot of rising air building these great, tall, vertically developed clouds. Now, we've built air masses, we've looked at how they're coded. Let's start talking about what happens when they move, and specifically, let's look at the ones that are likely to move into the continental United States. Well, first thing to remember is that we pay a lot of attention to air masses in meteorology simply because when they move, they bring all of their characteristics with them. So if it's summertime and a maritime tropical air mass moves up from the south, it's going to be warm and really humid because it came off of the ocean. We usually experience really hot, humid, muggy days with high heat indices when a maritime tropical air mass is around. Or maybe a little closer to home in Michigan, sometimes we get a continental Arctic air mass that comes down through central Canada and then moves into the United States and brings some really astonishingly cold conditions with it. Notice that as it moves out of the source region, the longer it spends out of the source region, the more those characteristics are going to start to change a little bit. It started off maybe as negative 46 degrees Celsius, but it's not going to stay that way all the way down into Houston because as it moves, it's crossing over warmer land. It's going to start to move to a latitude where there's more sun coming in and heating up the ground. And so that air mass will naturally start to change. The longer it spends out of its source region, the more its characteristics start to drift and be modified a little bit. We'll talk more about air mass modification in the next section. For right now, though, let's take a look at the ones that are the most common air masses here in the United States. All right. Now, I'm going to work my way through these air masses by latitude belts. So if we take a look, first of all, at the furthest north, right, way up here, we have the Arctic source regions, then we have a belt of the polar regions, and then we have the belt of the tropical regions. So that is how the Arctic, polar, and tropical letters are assigned to our air masses. Depends on the belt in which they formed. Now, the difference between the two maps that you see here is that the one on top are the air masses that move into the US in the wintertime, and the one on the bottom are the summer US air masses. They're similar, but there are a couple of small differences. The main one being that even central Canada warms up in the summertime. So, what might be an air mass with temperatures in the 10s and 20s that comes out of Canada in the winter would maybe be more like a cool summer day in the 60s in the summer. It's still a continental polar air mass. So remember that the characteristics will change in appropriate ways through the different seasons. Now, if we take a look first at this air mass that's the furthest to the north, the continental Arctic, this is an air mass that we only experience in the US in the wintertime. Main reasons for that. In the wintertime, the polar jet stream comes further south, and remember, it flows west to east over the United States, and it's on the north side of it where that continental Arctic air would be. If the jet stream dips even further south, that really allows that cold air to escape the Arctic and move down into the US. Now, in the summertime, the jet stream actually weakens a bit and it moves quite a bit further north. And so it really does help to kind of hold that continental Arctic air mass in place. And we don't typically see it here in the US in the summertime, thank goodness, right? But it is definitely a big player for some of our major polar outbreaks that we have in the winter. Now, while I'm on this topic, you have maybe heard in the news in the last, I don't know, couple of years, people talking a lot about something called the polar vortex. It's probably the most widely misused, misunderstood term that the media has picked up in recent years. The polar vortex is really just a big system of winds that kind of circulates around the North Pole, and there's one in the South Pole as well. And I like to think of it as a bunch of collie dogs that are running herd on a flock of sheep. Good sheep herding dogs are going to run around that flock in circles. They're going to nip at the heels of any sheep that tries to stray away, and they're going to keep that flock in a nice, tight little pack. But if the dog gets tired and lays down and goes and takes a nap, the sheep are going to start to wander off and break away from the pack. The winds of the polar vortex are very much like these sheepdogs. When they are really fast, they tend to blow in a nice tight circle around this Arctic air mass up here, and they keep it all rounded up and in this tight little pack, and they really help keep it in the Arctic. It's when the polar vortex weakens, right? The collie dogs go to sleep, that this air is allowed to start to kind of wander and break away from the Arctic region and come down into the US. So honestly, in the wintertime, if we have a really big cold outbreak and you are swearing at the polar vortex, wishing it would go home, you really should be cheering for the polar vortex, sending it some vitamin C or something. I don't know. We want it to be strong so that it holds that super cold air in around the Arctic. All right, let's move down to the air masses that come from the polar belt. The United States experiences both maritime polar air masses that we get off of the North Atlantic and the North Pacific, and we experience continental polar air masses that come down out of Canada. Which of the two maritime polar air masses do you think is more likely to play a key role in US weather? The one off of the Atlantic, or the one off of the Pacific? If you answered Pacific, you got the answer right, because you need to remember that weather moves from west to east here in the United States. And so the maritime polar air mass off of the Pacific is one that's more likely to work its way into the continental United States. But we don't want to discount the maritime polar air mass over here in the Atlantic. It actually can get pulled into the US by a weather system called a nor'easter, which is a nickname for a mid-latitude cyclone that you're going to be learning about, that is rotating counterclockwise. And when it moves up the coast over here, that counterclockwise flow is able to pull that humid air off of the Atlantic and feed it into the system. And because of that, it's able to make a lot of snow. These tend to be big snowmakers and big newsmakers in the eastern United States. All right, so we have maritime polar and continental polar. We do get both of these in the summer and in the winter, and they are two of our most key players for our weather. Now, the final belt down here is the tropical belt. The big player in US weather here is the maritime tropical air mass, particularly the one here that comes up off of the Gulf of Mexico or the central tropical Atlantic. These move into the United States through the southeast and are a really significant component in most of our cold fronts and warm fronts that we're going to be learning about. Now, we do also get some maritime tropical air from the Central Pacific, and that one kind of moves up into the US, particularly in our summer months, and plays a bit of a role in the monsoon season in the American Southwest. There's one more air mass on this list, and that is this little guy down here in the summer months only. It's the continental tropical air mass. Continent means dry, tropical means hot. This is the air mass that sometimes forms in northern Mexico, West Texas, New Mexico, sort of our desert, really dry, arid regions, and is sometimes a player in a situation called a dry line that you will learn about in association with fronts and mid-latitude cyclones. Dry lines basically occur when this really dry air out of the desert Southwest moves up and interacts with this humid air mass that's coming in off the Gulf of Mexico. And it can create some situations that generate thunderstorm activity. So you will see a little bit about our continental tropical air mass here, just maybe not as often as you'll hear about the others. It is a summertime air mass only. In the winter, there's just not enough heat to generate continental tropical air masses. So these 5 that you see listed here are the key 5 that we find here in the United States. And though we get all of them at some point in the year, just the key takeaways here, we don't get them all year long, right? Continental Arctic is only in the winter, continental tropical only in the summer. The other 3 we can have throughout the year, but their characteristics are going to change seasonally, right? It'll be a little warmer in the summer, a little cooler in the winter. One more thing I want to show you before we move off of this map. Do you notice how if we look, here's the Rocky Mountains, kind of right in here. Do you see how this cold, dry air out of Canada can kind of filter down along the Rockies? And then coming up along the Rockies, we have this warm, humid air from the south. And right here in this area of the country is where they collide. Can you think of a nickname for that area of the country? If you said Tornado Alley, you're thinking of the one I am. One of the key reasons Tornado Alley exists where it does is simply because this is where this cold, dry air mass collides with the warm, humid one. We're going to talk a lot more about that when we get to severe weather and mid-latitude cyclones in a coming section. Up next, we're going to talk a little bit about air mass modification. For now, though, those are the key ones that impact the US, and you'll be seeing a lot more of those in the days to come.